And everybody should have access to the questions that I'm talking about because they're all here. Everything to do with exam reviews, all notes or lecture notes, the study guide will be posted here. And whatever I cover in today's lecture, I'll also post the notes here. Okay? Every question in your final exam will be from this document. Every question. I mean, different numbers, but straight from this document, right? No, nothing will be extra outside. So in today's class, I will talk about, this is not your class. And please make sure the videos I post on YouTube, look for your class time. So I'm teaching 1 more to 10, and that class runs from 3 p.m. That's not the same content as this class. So if you click on, let me just go back here and just make sure you're on the right track. So you'll go to my exam review videos. From exam 1 to 3, all is relevant. 6.2 is not covered for the final exam, so ignore that. And if you click on the brief calculus exam review videos, you go here, it will take you to my YouTube channel. And you see, you look for the 6 p.m. one because these are meant for your course. The 3 p.m. is a different course, okay? And watch all the exam review, part 2, part 3, they're all relevant. And I'm gonna post this one too there. So in today's lecture, I want to discuss all the new topics that you haven't been tested before, which is 6.1 and 6.3. Because until consumer and producer surplus, you already wrote an exam, right? Exam 3 was until consumer and producer surplus. So after that, I will go over all these topics once more on Wednesday so that you are fully prepared for the exam. But this is all the previous reviews that I've combined. The new topics that you haven't written an exam on are starting from here. So you wrote an exam on consumer, there you go, right? 6.1 and 6.3, improper integrals and integration by substitution are the two topics that you haven't been tested on. And the group work today will also be from 6.1 and 6.3 because I've taken group works already for the previous topics. You have written quizzes in class, right? Already. So today's group work or quiz will be on 6.1, 6.3. So take notes. I will be picking problems from this document right here. And I have some more problems from another instructor because they thought it was relevant. So just, more things for you to practice. And I'll do plenty of problems for substitution in today's class. And then we'll move on to integration, improper integrals. Okay? Anybody has any questions so far? Okay, good job. So I'm picking the topics from more problems. So this is Math 210, final exam review. Final exam review. And this is for my 6 p.m. class. But I know which document to post. Okay, I'm going to talk about section 6.1 from your exam review document, which is integration by substitution. Now I'll give you one hint. If you just pay attention and can solve every question that I'm solving right now, you should be good for the exam. So just make sure, put your phones down, catch up with friends later. Just pay attention to today's lecture, and then at least you're set for 6.1 and 6.3. Okay? So I'm picking part, let's pick part E from the question number 1. When I say more problems, so this is part E. So I will tell you in exam that I want you to solve this using integration by substitution. So that will be your hint. I will want you to pick a u. I will want you to find the du over dx. And then I will want you to perform the new integral and all that. So you will know that this question requires integration by substitution. So the question is x times x squared plus 1 to the power 10 dx. Okay. So this question will be divided into 3 parts like we did in the lecture. We began with part 1. The first thing you have to do for integration by substitution is find your u. So if you look at x squared plus 1, the u is always going to be the inside function or the function with the higher power, or if it's e raised to something complicated, that is always going to be your u. There's one more technique that you can pick your u. You pick your u, and then once you do the du over dx, it should be really simple, the derivative. In this case, that's 2x, right? So what is du? Du is 2x dx. And that is it. This is step 1. Figure out your u, find du. Okay, so far, good, everybody? Step 2 is when you try to balance your integral. So we start with the original question first, and we move the complicated part. So complicated part is that quadratic raised to power 10 to the front, and we move everything to the back, right? Why do I do this? You'll see in a minute. So I move the complicated part to the front because that's going to be u anyways. Now, what am I missing in this question? This is where you do the balancing part, right? So my du has a 2 extra, right? My question, when I move stuff around, doesn't have a 2. So I have to balance this integral. Balance. I have to multiply this thing by a 2. But as soon as you multiply by an additional number, make sure you want to divide by a 2, right? And that's the technique. We want to make the everything extra match exactly u. Now this is matches exactly du. Okay, step 2 clear to everybody? I rearrange my function and I match it with the du exactly. Now step 3 is, now you rewrite the integral in terms of u and du. So because the inside function, which was the complicated part, I assume that as u, that becomes u to the power 10. And this is matching exactly as du, right? That's why we did the balancing part. It becomes u to the power 10 du. And now this integral is easy peasy. Everybody knows how to integrate that, right? This will be half. You add 1 to the power, divide by it, plus a c. But you're not done here. Make sure you plug in the original u. U was assumed to be x squared plus 1, the power 11, divided by 11. You could simplify more, but leave it here. This is good enough with me, okay? This clear? Step 2 is you balance your integral. Make sure du matches exactly. Final answer. Every question will follow 3 simple steps. Okay, can everybody do this in the exam? Anybody, any questions? Alana, where are you? Not here. Okay. So let's do more problems. We have plenty of problems I want to solve with you guys today. I'm going to solve number F. Same question, number F. This is 15x. Now we don't panic if we see a square root, okay? The inside function is your u. So negative x squared plus 7 dx. Of course, I'll tell you in exam, if you see this question, I will let you know that you have to use integration by substitution. Okay, tell me, what's going to be my u? Here's a hint. Yes.
U is negative x.
Exactly. How many? Do you agree with Tim? Everybody agrees? That's your u, the inside function. And there is another hint. Because if you differentiate your u, the answer should be simpler. Yes.
I also want to know, in the exam, are you going to have everything set up where it's like by section? Meaning, like, will you have on the exam to be like section off as like 6.1? Or
No. No, I will not. But I will give you hints and formulas wherever. Yeah. Okay. Yes. Consumer producer surplus, don't memorize. Yeah. So far. Well, that you have to memorize. That's like the tangent formula, right? Okay, that we'll talk after. Now, so we have du, everybody can do until here at least, right? Can figure out their u, find their du, right? Good. Okay. Next we move the complicated part to the front and move everything else at the back. You see how I'm dealing with this? I'm moving everything else to the back, but look, what am I missing here? I'm missing a -2 multiplied with x dx, right? So I need to balance this question too. So what will I do? I multiply by -2, but as soon as you multiply by a number, you have to divide by it. Okay, everybody on the same page with me? So we move the complicated part to the front. Yes, you could, but we'll just stick to the process. Yeah, you can improvise as you want, but I want to stick to one process that makes sense to everybody. Okay, so we balanced everything. This matches du exactly. And now we rewrite the integral. So I have 1 over -2 integration. Inside the square root was u, and that was the whole plan, right? And then I have 15 du. And now you can move it out. This makes sense? The whole point of making it exactly match du so that you can replace all that with du. Exactly. Okay? And then I move the 15 out. How do I integrate a square root? No, you must be champions in integrating this at least, right? So this is, you add 1 to the power, it will be 3 over 2, divide by it, plus c. But I'm not done here. I have to replace the u back with the whatever was the substitution to begin with. And that's the final answer. Right? Okay, so expect a question like this in the exam. I want to solve more from integration by substitution. Let's solve. Now I'm solving the question number 1 on page 15, part F. This is with the limits. Question number 1, part F, and this is on page 15 of your review. Okay, this is posted for everybody. -1 to 1, 5x squared plus 1, and then I have 5x cubed plus 3x to the 10 and dx. Now, there are too many ways to check what is going to be the u, right? It's going to be the one with the higher power, the one that's inside a function, and the one that looks more crazy. So my u is going to be 5x cubed plus 3x. Du is going to be, what is it, 15x squared plus 3. Now this question I picked for a reason. You see, when I try to when I try to rearrange, how do I rearrange this function to make it make sense? So I have -1 and 1. I move the complicated part, which is the bottom part, right? Plus 3x to the power 10. And then I move the rest of it, the top part, with dx. Now, does it match the du exactly? No, it doesn't. It needs to be multiplied by something. It has to be multiplied by 3. You agree? Right? So this is a tough question because the du, if I take a 3 common here, so sometimes it can be tricky, okay? So I have to multiply by the 3, which is extra. Okay, anybody any questions here? I do need balancing for this integral because I have to multiply this by a 3, then I have to divide it by a 3, and now it matches du. And we have to do that because we want to replace the whole thing with du, right? So it will be 1 over u to the power 10 du. Make sense? And everybody knows how to integrate from here? It becomes negative power. Be very careful with negatives, okay? You are adding 1, it becomes -9. Now there is one step extra in this problem. The extra step is it's a definite integral. So you have to find a number. You cannot just replace the u and leave it there, right? This requires a little bit more work. So if this question comes up in exam, it will be very expensive question. Many subparts, it will be worth a lot of points. Okay, so make sure you complete it fully. So I have 1 over 3, and then I have a u, which was 5x cubed plus 3x to the power -9 over -9. And then I plug in the limits. So then it's just the same old that you have done. 2 big brackets. In the first bracket, you put the upper limit. In the second bracket, you put the lower limit. And that would give you a number. Final answer. Good? So this is similar to what we have done already, but we have one extra step where we have to apply the upper limit and lower limit. Just be careful, okay? There will be no word problems from 6.1, 6.3. It will be questions like this. So make sure you practice all the integration by substitution and other stuff. I want to do one more of integration by substitution. This is on page 15, part E. Any questions, anybody? So this is page 15, and we are solving part E. Now this is also important. This might expect it in the, what do you call it? Multiple choice. If you see ln and x together, the natural log is always your u. Remember that. Natural log x is always the u substitution. Okay? I'll let you know right now. And this question has a typo because as you can see, the x should have been at the bottom. I found a typo already. Right? So fix this. The x is in the bottom. And no matter what question I give you in substitution, if it involves a natural log, just make the natural log a u. Okay? So what happens if I make the natural log a u? So I've got u equals natural log. What is du? Now this is where you have to memorize these formulas. The derivative of natural log is 1 over x. So the integral of 1 over x is integration of 1 over x. Natural log, right? It goes vice versa. So try to remember at least one formula, then the other ones will follow, right? That's the opposite of differentiation. Okay, so I got that. Let's just write it out, rewrite our integral. So I have 1 over ln x. That's the complicated question. Oh, because that, then finding u prime will involve a product rule, right? If you let your u to be 4x ln x, then you see you have to do a product rule here. You could take it out. Let's take it out. Let's take 3 or 4 out. Happy? Now, 1 over x dx. You could take it out. There's nothing wrong with it. But you see, my everything else, it's matching exactly. Now, that's one more hint. If you pick your u to be something goofy, and you have to apply power rule, then you have to apply chain rule or product rule, you did something wrong. Okay? The u will be straightforward. Question? Yes. There's no need to balance because it matches du exactly. Right? This is matching exactly, so I don't need to balance. It's already perfect. Question? Oh, that's why I changed it. There was a typo. So there is a, did you see this typo? If the x is in the numerator, then you can't simplify this question into 10 at least. Okay? So x has to be in the bottom. And now it's easy peasy, lemon squeezy. It's 1 over u. That becomes du. Now, what is the integral of 1 over u? There you go. So you have 3 over 4 ln u plus c. But what was u to begin with? Ln x. So you have ln of ln x. Now that's not goofy. This is okay. Good. Okay, this is what I wanted to talk about. I did post notes on my Canvas. I solved a bunch of problems. If you go here, go to home, and if you go to chapter 6, because these are the only type of problems that I need you to review, right? Review problems. So I have more solutions posted here, more examples. So make sure you review those also. Now move on to convergent and divergent integrals. So this is section 6.3. Section 6.3. These are the improper integrals. Now this is difficult because you have to use a lot of background. You have to use the limits information, and 3 things I want you to memorize for this section. E to the power negative infinity is 0. Okay? You must practice all the problems on this section. And anything over infinity will give me 0. And anything over 0 will give me infinity. That's a bad number, right? And anything raised to the power 0 is, good job, is 1. So just remember these things, because I don't want you to rush or panic and find this limit during the exam. Just remember these 4 things. Okay, so you can apply it right away. And if I have e to the power infinity, that will give me infinity. Okay. Alrighty, now we move on to the problems. So the first problem I have for you is page number 15, part D of section 6.3. Question number 2, page 15, and we're solving part D. As soon as you see something crazy limit, you already know that this is going to be a improper integral problem, because I don't have a number here. One of the bounds is infinity. So immediately know this is a question of improper integrals. What's the first step we do? We rewrite this integral using limits. So we will rewrite this. We will introduce a variable where the crazy bound was, and we'll make that variable approach to infinity. You see what I did? And then you copy the function as it is. Because now we can simplify it. So as soon as you see something negative infinity, positive infinity, something crazy going on, replace that with a variable, introduce limits. And now integrate. Can we integrate this part? This is something you have done before. This will be limit b approaching to infinity. And I can make it a negative power, right? So I've got 2 to b, 9x to the power negative 3. And when I integrate that, I will get limit b approaching to infinity. And I've got, you're adding 1, so you get negative 2 divide by negative 2. Right? I integrate as usual. I'm using the power rule. The only different thing I've done is replace that infinite bound with a variable. And then we calculate the limit at the end. Okay, can everybody do this in the exam? At least this far. Okay, now we don't want to blank out because I've seen in the past. So you know how to do it until here, and then you plug in. So I'll make 2 big brackets, right? I'll have the bracket and then another bracket. This will have the upper bound in place of x. This will have the lower bound in place of x, right? And what will I get? So I have limit b approaching to infinity, and I replace it with the upper bound. So I've got 9 b to the power negative 2 over negative 2. Subtract 9, put the lower number in the second bracket, right? Now where do we go from here? Now I would recommend that if you see a negative power for the improper integral, especially if you see a negative power, you move it to the bottom. So it makes more sense when you plug in the infinity. So look, what happens here? It will be 9bo. Because the power is negative, I can move it to the bottom, right? And this is just going to be a number. And this is, well, 1 over 4 if you simplify it. If you move that 2 to the bottom again. But I have to remember I'm applying the limit approaching to infinity. So when I substitute infinity in place of b, what do you think I'll get? I'll get something over infinity, right? And what is anything over infinity? There you go. So just after this step, it gets the limit, it becomes a limit problem. So you substitute the infinity in place of your variable, or negative infinity, depending on the question. And depending on that, your integral will converge or diverge. So this integral, because I got a nice number here, right? This means that this improper integral converges to a number. Improper integral converges to 9 over 8. Yeah, question. Even then, anything over infinity or negative infinity, it's still going to be 0. Okay? So even if you are multiplying it by a number, or if you're squaring infinity, think of infinity as the ocean. So if you add something to the ocean, you add a bucket of water, it's still the ocean, right? Infinity remains the infinity, no matter what you add to it. If I subtract something from the ocean, I take a bucket of water, it still remains infinity. So if you add a number to infinity, if you subtract a number to infinity, you multiply a number, you divide it by anything, it still remains infinity. Okay? That's how you remember. Okay, this integral converges. Let's do one more where we have, I wish I had, okay, let's do this one. This is page 15, question number 2, part C again. So now I have a negative infinity going up to 2, and I have x to the power 3 over 2 dx. I can clearly see the problematic bound is going to be this one, right? That gives me the first step. I replace that with a variable. You pick whatever variable you want. I'll pick a. A goes from 2, and I've got x 3 over 2 dx. Good? So far clear? Everybody can do this step in exam? How many would like me to explain again? Okay. Yes. Oh, you want me to explain again, or you're just doing it to be nice? Okay. So the only thing you do is you take the problematic bound. In this case, it's negative infinity. You replace that with a variable and make sure you make that variable approach to the exact bound. Right? You must have questions. You cannot understand everything. Or maybe I'm too good. But ask me questions, okay? Alrighty. So now how do I integrate this? So I have limit a approaching to negative infinity, and I'm going to integrate that. So you add 1 to the power, what's that going to be? 5 over 2, divide by 5 over 2, and I've got a up to 2. Then I just solve it like a definite integral problem. You take the upper limit, replace the x with the upper limit, and you take the lower limit, replace the x with the lower limit, which is a. But in this case, I can already see something problematic is happening. I have negative infinity raised in the numerator, right? So I don't even need to solve anything, because even though I have a nice looking number here, but I still have negative infinity raised to some power, right? You add something to infinity, it doesn't affect, still gonna be this improper integral diverges, because it's not converging, it's not approaching a nice real number. So in this case, we say improper integral what happened here? Integral diverges. Good. I want to pick one question from that page 17, the one from the other course, which I think is relevant. Well, let's do one with the power of e. Okay, question. You can, I will not be too strict about negative or positive infinity. Okay, so don't ignore that. Yeah. Oh, that will not be in the question in exam. Okay, so look, I'm doing part B on page 17. So I want to do an exponential question. So this is part B, and this question is picked from page 17. We're still in improper integral section, and I have negative 2 to infinity, and I have e to the power negative 3x. Okay. Now, Well, what's the problematic case here? And for these ones, I also have the answers posted for you also, right? Okay, so I see the problematic guy. What do? I make it a variable. I make that variable approach to that infinity and replace it in the integral. Right? That's step one. We do this step. Now, what is the shortcut formula? Do you recall that? Recall shortcut formula for kx dx is? I don't want you to use substitution here, okay? Use the shortcut formula for this problem. All right, so now I integrate using the shortcut formula, and what do I get? E to the power negative 3x divided by negative 3. I plug in the limits. I've got 2 and b. Limit b approaching to infinity, and I've got e to the power negative 3 times b, divide by negative 3, subtract the lower limit, so I'll have e to the power negative 3 times negative 2, divide by negative 3. Good so far? And even if I'm plugging in infinity, so once you plug in the value of b as given in the limit, then you can get rid of it. So I've got e to the power negative 3 infinity divide by negative 3, and I've got e to the power 6 over. And what is e to the power negative infinity? 0. Negative infinity is 0, right? And you add that, you got over 3. So this integral converges, this improper integral converges to e to the power 6 divided by 3. Good? Yes.
So you only care about negative or positive.
Yes. Okay. If you have something in the denominator, we don't care what sign it is, it will be 0.
If it was a positive 3, would it be
it would be divergent. Yes. Infinity, yes, you're right. Good. This is it. These are the questions. Expect one of these in the exam. I will go over the previous reviews one more time on Wednesday because I have to give you the group work. Okay, these notes will be posted. Let's end this meeting. Why can't I end this meeting?